But before we get started, don't forget to like and comment on the video. After your mind has been completely blown away by the video, you can also subscribe for more amazing stuff like this. Scientists recently discovered cosmic structures that are more than 60 times the size of the Milky Way. The sheer magnitude of these bodies defies logic and changes everything astronomers thought they knew about the universe. Attempting to comprehend their vastness will undoubtedly leave you feeling weak and dizzy. Started foreign music. Thai is a supercluster, and the Boötes superclusters are well known primarily because they are located next to and slightly behind the Boötes void, one of the most well-known voids in the universe. It was one of the first significant voids to be discovered in 1981, and its center is located approximately 700 million light-years away from us with a redshift of 0. There have been no scientific studies of the superclusters in Boötes, despite the fact that they are much larger than the Virgo supercluster and that many closer superclusters are thought to be more interesting. The Boötes void has been the focus of several scientific studies. 052 and a diameter of approximately 300 million light-years. Within Boötes, there are two superclusters that exist 1 billion light-years from Earth, the closest of which is approximately 830 million light-years away, and the second one sits directly behind it at a distance of roughly 1 billion light-years. It was discovered in 1981 by Robert Kirshner, Augustus Omler Jr., Paul Schechter, and Stephen Schechtman. The scientists surveyed galaxies in 3 small areas of the sky in the Boötes void region and noticed a large gap where there were no galaxies. Over the next few years, in 1983, they confirmed the existence of the Boötes void, and in 1987, they published a paper in which they created a map of the void. Other astronomers quickly started investigating this void. In 1987, J. Moody, R. Kirshner, G. Maplepine, and S. Gregory published a paper listing 8 galaxies found in the void. With these findings, astronomers thought there might be more to discover, and finding galaxies in the Boötes void quickly became a popular pastime among some astronomers. In 1988, M. Strauss and J. Hakra announced the discovery of 3 more galaxies. In 1989, G. Al Ring, G. Baumann, R. Kirshner, and R. Marsky announced that they had found 15 galaxies in the Boötes void. By 1993, astronomers had found 27 galaxies in the Boötes void, which were listed in a paper by Cruzen D. Weistrop and C. Hoops. However, they kept finding more, and by 1997, there were 60 known Boötes void galaxies, which is still a relatively small number considering that a typical region of this size would typically contain thousands of bright galaxies, are typically found close to the void's edges, so at its center, there probably are a number of galaxies that have yet to be found. The Saraswati supercluster was found by researchers from the Inter-University Center for Astronomy and Astrophysics, IUCA. It covers a vast region of space that is about 600 million light-years across, and the team estimates that its combined mass is more than 20 million billion suns. In addition to its remarkable size and mass, the discovery of this structure is so astronomers Joydeep Bagachi and Sashir Sankyan, 2 of the team astronomers, explain the Shapley concentration or the Sloan Great Wall in the nearby universe. Another distinctive feature of Saraswati is its remote perch, which is about 4 billion light-years away from you and me. This is significant because astronomers haven't actually identified that many superclusters yet, meaning Saraswati is joining the ranks of some pretty elite company. The researchers located Saraswati by looking at data from the Sloan Digital Sky Survey, and they claim that the supercluster contains at least 43 galaxy groups and clusters comprising about 400 galaxies. The most exciting thing about the Saraswati supercluster, according to Team Sumac Richard, who also initially assisted in identifying the Shapley concentration, is that it is at least 8 to 10 times closer. This is the first time that we have seen a supercluster that far away. The CFA2 Great Wall, also known as the Como Wall or the Great Wall, was discovered in 1989 by Margaret Geller and John Hookra, based on redshift survey data from the CFA Redshift Survey. The distance from Earth indicates that the light we see has traveled an incredibly long way to get here, showing us what the supercluster looked like when the universe was only 10 billion years old. The CFA2 Great Wall is a giant galaxy filament that is known to be among the largest known galaxy superclusters. As the name suggests, the galaxy is great in the observable universe because of its size in comparison to other typical galaxy walls. The CFA2 Great Walls are between 50 and 750 million light-years in size, with a width of 200 million light-years and a thickness of roughly 16 million light-years. The structure's closest point to Earth is approximately 300 million light-years away, while its furthest point is approximately 550 million light-years away. It contains 3 equally massive galaxy superclusters, known as Hercules Coma, and because of the zone of avoidance, which is a patch of the universe that we cannot see because of light absorption in the Milky Way galaxy's plane, where Earth is located. Leo, there is no concrete evidence of how far the wall extends. The zone of avoidance is composed of Milky Way gas and dust, which blocks astronomers' view and makes it impossible to determine whether the wall ends or continues farther than they can currently see. For context, roughly 20% of the universe is obscured from our vision, because in the standard model of the universe's evolution, structures like the Great Wall form along and follow web-like strings of dark matter. The general idea is that this dark matter dictates the structure of the universe on the grandest of scales. Dark matter gravitationally attracts baryonic matter, and it is this normal matter that astronomers see forming long, thin walls. X-rays and infrared light observations allow astronomers to get past this block of dust to our galaxy stars and interstellar dust at optical wavelengths. Music, Callum supercluster. The Callum supercluster is a potentially massive supercluster that was found in the 1980s and spans 910 million light-years. To put it in perspective, consider the Laniakea supercluster from the Great Attractor episode, which is 520 million years away and contains an astounding 100 quadrillion stones in hundreds of thousands of galaxies. Now that you have a better idea of how big the Laniakea supercluster is, let's compare it to the Callum supercluster. The Callum supercluster is 10 to the power of 29 times larger than the Sun Pisces Cetus supercluster complex, which was discovered in 1987. It is 1.7 times more massive than the Linea Chaos supercluster, meaning it is nearly twice as large. Its closest point to Earth is 1 billion light-years away, while its furthest point is 2.31 billion light-years away. Additionally, the Callum supercluster contains 8 to 300 galaxy groups, 50,000 giant galaxies, and only roughly 500,000 dwarf galaxies. According to Tully from the University of Hawaii, the Pisces supercluster complex, which is thought to be roughly 1 billion light-years long and 150 light-years wide, and is one of the largest structures in the observable universe, contains at least 60 galaxy groups and clusters in a diameter of 110 million light-years. In addition to our famous Milky Way galaxy, Virgo makes up just 0. The complex is made up of 5 parts, including the Pisces Cetus supercluster, the Perseus-Pegasus chain, which contains the Perseus-Pisces supercluster, the Pegasus-Pisces chain, and the Sculptor region. Interestingly, the Pisces Cetus is not the only structure that contains Virgo. The Lania Chaos supercluster also holds it. The Cetus is approximately 1 billion light-years in length and 150 million light-years in width, and its estimated mass is approximately 10 to the power of 18 solar masses, according to Tully, who made the discovery. The structure was named after the Pisces Zeta superclusters, its richest superclusters, the Perseus-Pegasus filament, which is a galaxy filament that contains the Perseus-Pisces supercluster. It stretches for about 1 billion light-years away. from Earth and is thought to be one of the largest known superclusters. It contains the Sculptor supercluster, the Hercules supercluster, the Melania-Kia supercluster, which contains our Virgo supercluster, the Hydra Centaurus supercluster, and the Melania-Kia supercluster. In 1985, David Batuski and Jack Burns of New Mexico State University made the discovery of the Perseus-Pegasus filament, which is located next to the Pisces-Cetus supercluster complex in the universe. According to some accounts, Walter E. Bernheimer reported discovering portions of this clustering boss Great Wall before Clyde W. Tombaugh of Lowell Observatory, who was searching for trans-Saturnian planets in 1936, identified it as the Great Perseus-Andromeda Stratum of extragalactic nebula. Using the Baryon Oscillation Spectroscope survey, the BOSS Survey Salon discovered the BOSS Great Wall, a supercluster complex with 2 elongated, 2 large, and several smaller superclusters in early 2016. The structure is about 1 billion light-years in diameter and contains an incredible number of galaxies, of which about 830 are visible galaxies, and the rest are dark galaxies. The BOSS Great Wall's total mass is approximately 10,000 times that of the Milky Way galaxy, though its precise size has not yet been established. The Great Wall filaments are crucial because, on the largest scales, the universe resembles a cosmic web of matter surrounding empty vids, and these walls are the thickest threads unlike several other chained large-scale structures. It is safe to say that this Great Wall is incredibly large. Scientists primarily debate whether the supercluster complex is moving together or gradually separating as the universe expands, according to Joshua Sokol. In astronomy, distance is measured using the redshift phenomenon, which is based on the idea that as the universe expands, galaxies may expand. This means that the BOSS Great Wall's discovery has provided astronomers with a great opportunity to learn more about the large-scale structure of the cosmos. The South Pole Wall is a giant wall of galaxies that spans 1.4 billion light-years and contains hundreds of galaxies, with its largest parts sitting 500 million light-years away from the Milky Way galaxy. When scientists were still working to find the South Pole Wall, they used a different but comparable method to measure the distance, measuring the redshift and the motion of the galaxies around one another as they pull each other by gravity. This method also helped them detect the mass coming from invisible sources, as they dissipate from us and their light stretches to longer wavelengths, giving them a redder coloring. Researchers have found it difficult to confirm the precise points where these structures start and end. The scientists who mapped the South Pole Wall are still convinced that they have not mapped out the entire structure, but in their paper they mentioned that they could not fully map out the structure. The matter is the dark matter that affects the movements of the galaxy. They could also map a 3D matter distribution in and around the zone of avoidance. Their study results in a map showing a giant bubble of material centered around the southernmost point of the sky, confirmed the full map of the South Pole Wall until a thorough map of the universe was created. The Sloan Great Wall, which is about 1 billion light-years from Earth, is a cosmic structure made of a giant galaxy filament. It was found in 2003 by a team of Princeton University scientists using data from the Sloan Digital Sky Survey. The Sloan Great Wall is a massive wall that is between 1.8 and 2.7 times longer than the CFA2 Great Wall. It is 37 billion light-years long, which is about 1/6 of the diameter of the observable universe. It is roughly 500 million light-years long, 300 million light-years wide, and 15 million light-years big. In 2011, critics claimed that the Sloan Great Wall was not a structure in and of itself, but rather a chance alignment of 3 structures. Klaus-Capusano LQG. The Klaus-Capusano Large Quasar Group, or LQG, is one of the most unusual cosmic structures known to man. It was discovered in 1991 and is a giant structure made up of 34 quasars that are 9.5 billion light-years away. It is about 2 billion light-years long and 1 billion light-years wide. For a variety of reasons, including the fact that they are both situated in a lumpy region that is not typical of other regions of the same size and redshift in the universe, the massive LQG is located 8 billion light-years away from another giant structure that appears further down on this list. Some researchers have theorized that because the structures are so close together, they might actually be a single structure connected by an unidentified intergalactic filament. But there is no evidence to support this theory. Evidence to back up this assertion, but U1.11 is one of the largest known LQGs. Its estimated maximum diameter is 2.2 billion light-years, and it contains roughly 38 quasars spread across an approximate distance of 8.8 billion light-years. Robert Klaus found it in 2011 during the Sloan Digital Sky Survey, before the massive LQG, the U1, was found in 2012. At the time of its discovery, 11 was the largest known structure in the universe, surpassing the 20-year record held by Klaus. Capasano LQG. Its existence implies the evolution of a large galaxy filament, and it is situated within the Virgo and Leo constellations, roughly 2 degrees away from the Klaus-Capasano LQG-C ICLQG. It is known as U1. Since it is located at redshift Z-Kurbuscher 1.11, it is roughly 0.8 billion light-years away from Earth. It is next to the CCLQG and reasonably close to U1.54, another LQG. The giant arc, which is a collection of galaxies arranged in a curved cosmic structure that extends 3. Alexia Lopez, a doctoral candidate in cosmology at the University of Central Lancashire, UC Land, in the UK, claims that the giant arc, a recently discovered structure that is so enormous that it challenges astronomers' preconceived notions about the cosmos, is an epic arrangement made up of galaxies, galactic clusters, and a lot of gas and dust. It is 9.2 billion light-years away and spans across approximately 1 to 15 of the observable universe. Lopez was making maps of objects in the night when the discovery occurred. As light travels through the matter between the Earth and the quasars, various elements absorb it, leaving behind telltale traces that can provide researchers with crucial information. In her research, Lopez used the light from approximately 120,000 quasars, distant bright cores of galaxies where supermassive black holes consume material and spew energy, to determine the distance to the intervening gas and dust. She also determined the material's position in the night sky. An intriguing feature of the giant arc is that it is larger than other massive clusterings, like the Sloan Gray Wall and the South Pole Wall, both of which are dwarfed by even larger cosmic features. The enormous LQG, which is thought to contain roughly 73 quasars with an estimated size of 4 billion light-years, was originally named U1. These quasars act as spotlights in a dark room, illuminating this intervening matter. On January 11, 2013, Roger G. Klaus and his colleagues from the University of Central Lancashire in Preston, United Kingdom, reported a grouping of quasars within the vicinity of the constellation Leo. They used data from the DR7 QSO catalog. Of the comprehensive Sloan Digital Sky Survey, a significant multi-imaging and spectroscopic redshift survey of the sky, and they claimed that the group was the largest known structure in the observable universe. This was because the group's average redshift was 1.27, which places it at roughly 9 billion light-years from Earth. The enormous LQG was first found in November 2012, but it took 2 months to confirm before the announcement. Since its discovery in 2013, the scientific community has given it a lot of attention, in part because of its enormous 6.1 quintillion solar masses, which made it the most massive structure known to the observable universe. However, it has since been surpassed by a much larger structure, and it is also very near to the Klaus-Capasano LQG U1. The 28 giant GRB ring is a ring of 9 gamma-ray bursts. What's interesting about this structure is that it was found almost by accident in 2015. A group of American and Hungarian astronomers, led by L.G. Balázs, We're using the gamma-ray BERT correlation method to analyze data from various X-ray and GRB telescopes in an attempt to find structures. Gamma rays are released during a supernova, and if a dense star collapses, it may also indicate energy from star formation. After conducting additional testing and analysis of the GRB cluster, scientists found that the sample had a higher concentration than the average level, indicating yet another cosmic structure. However, the supercluster can explain the significant distribution of GWABs due to its connection to star formation, and because the ring shape is not random, so they came to the conclusion that it must be a real structure. The gamma rays on the Hercules Corona Borealis Great Wall is one of the largest structures in the universe. Gamma-ray astronomy found another object that would become the largest structure in the universe. The giant globular ring is located approximately 9 billion light-years from Earth, with a diameter of approximately 5.6 billion light-years and a redshift between 0.78 and 0.86. It is so powerful that it would probably destroy life on Earth if it were in its path. In 2013, astronomers using data from the Swift spacecraft discovered a cluster of gamma-ray bursts, or GRBs, which were quite close to one another and clustered in higher quantities than astronomers had anticipated. This suggested the formation of a massive object. The Hercules Corona Borealis Great Wall is 15 to 17 billion light-years from Earth and has a diameter of 18 to 23 billion light-years. It also contains 283 GRBs. Though some studies have cast doubt on the existence of the in 2020, the original group of discoverers and others published a paper stating that their analysis of the most reliable current data set supports the existence of the structure. However, they acknowledged that the Thetis satellite would be required to decide the question definitively. An interesting fact about this structure is how it got its name. John Rick Valdez, a Philippian teenager. They contend that the structure was discovered through biases in certain statistical tests without taking into account the full effects of extinction. Read about the structure's discovery in a newspaper and called it the Hercules Corona Borealis. Later, a science blogger used the same name to describe the structure in one of her broadcasts. Therefore, the name Hercules Corona may not be an accurate description of the structure, but it has become the most widely accepted. This brings us to the end of the list of the 15 largest structures in the universe. Which one did you find to be truly mind-blowing? Overseas.